we've been working with solving equations already with variables on one side. Now we're going to throw variables on both sides of the equation. And the rules don't change, just the strategy changes a little bit. So let's start with one pretty simple. 2x plus 14 equals 8x plus 2. Now I already know from previous problems that I've done that I want to end up with x equals some number. Now, to do that, I'm going to have to get all of the x's on one side. Now, you can move things in any order that you want as long as you're making legal steps. However, I recommend moving the smaller x term to the other side first. So, for instance, 2x is smaller than 8x, so I'm going to move the 2x to the other side rather than moving the 8x. That just saves me a little hassle working with more negative numbers than I need to when I'm getting a little further down the line in the problem. So I'm left with 14 on the left-hand side and 6x plus 2 on the right-hand side. Now this looks like something we've done before. I know that I can solve this by subtracting 2 from both sides, which gives me 12 equals 6x, and dividing by 6, which gives me x equals 2. I can check to make sure that that's the right answer by plugging 2 back in for x and making sure that I come up with the same answer on both sides. I get 4 plus 14, or 16 plus 2, both totaling up to 18. Now this type of situation is helpful when we're comparing two different functions. For instance, the book gives you an example of installing either solar or electric heating systems. Now the installation cost for a solar heating system is a $40,000 upfront cost, and then you're paying $100 per year, so 100 times the number of years. So after 10 years, we'd have paid a total of $1,000 in the cost, bringing us up to a total of $41,000 overall for the solar heating option. For the electric heating option, we have a $9,000 upfront cost, so it's much cheaper upfront, but we're paying much more per year at $1,200 per year. And so what we want to do is solve this for y, because the value for y that makes these two sides equal is the point at which the two costs meet. So obviously up front, electric is cheaper. And for the first several years, the electric heating will be a cheaper option. But there comes a point where that monthly savings in the bill is going to catch up to the upfront cost and balance it out. And so we want to find where that is. So we approach this the same way we approached the other one. We move the smaller y first. Again, that's a matter of preference. We could subtract 1200y from both sides and approach it that way if we want. This is just a matter of preference. So we're left with 40,000 on one side equals 9,000 plus 1100y. Then our next step is to get rid of that 9,000 from the right-hand side. Giving us 31,000, equal to 1100y. Now, if I divide both sides by 1100, 31,000 divided by 1100 is 28.18. And that's where it rounds off to. So that tells me that the solar heating system will have paid for itself in about 28 years. If all of these prices, per month stay the same, if the 1200 doesn't change, if the 100 doesn't change, then the savings for the solar heating would have caught up to the upfront cost and balanced that out after a little more than 28 years. And so this is the type of equation I can use to evaluate choices that I have to make in purchasing things such as heating systems or cars or things like that. So the next example they give you is with cars. Now, with cars, I could buy a Accord with an upfront cost of $20,925, but it's going to depreciate or lose value of $1,730 per year, as opposed to a Passat, which starts at $24,995 but loses value at $2,420 per year. So we see here that the Passat is worth more to begin with, but it's losing value faster. So we want to find when they will be worth the same. Again, I'm going to move the one with the smaller y value, but notice that this is the one with the smaller y value because it's a bigger negative number. And since it's negative, I'm going to add 2420y to both sides. Now, on the left, I have 20,925. And on the right, I have 690y. Oh, sorry. On the left, that's still on the left. I have the 690y. On the right, I'm left with 24,995. Now I'm going to move that 20,925 by subtracting it. And I come up with 690y equals 4,070. So I divide both sides by 690. And I come up with y being approximately equal to 5.9. So right around 5.9 or 6 years, both cars will be worth the same amount. And if I want to know what that same amount is, I could plug that y value in up here for this y, and that will tell me what they'll be worth. Now, I can also use this strategy to rearrange equations and solve them for different variables. For instance, this is my equation for the perimeter of a rectangle. Perimeter equals 2 times the length plus 2 times the width. Suppose I want to solve this for w. Well, I want to get w by itself. I move things away from it. So first I move things attached by addition or subtraction. So I'm going to subtract the 2l from both sides, gives me p minus 2l plus, equals 2w. Now I get rid of things that are attached by multiplication. And I get w equals p minus 2l over 2. Now, if I have another one like this, the strategy I like to use for this, if I want to solve for p, that is, I'm trying to get for p equals. I want to get p all by itself. So what I'm going to do is, instead of distributing, I'm going to divide out that v. That v is attached by multiplication to the entire side, so I can divide it out. Leaves me with p plus a equals k over v. Then all I have to do is subtract that a from both sides, and I get p equals k over v minus a. Alright, so I want you to try solving a couple of these equations. I'll give them to you, and I'll let you pause the video, work through them, and then you can replay the video or hit play again, and we can compare answers. So here's your 2 equations. Take your time, work them through. When you're ready, unpause the video, and we'll walk through them. Okay, so up here you might have chosen to subtract 2x from both sides first. That would give you 9 equals 3x minus 12. Then you'd add 12 to both sides. 21 equals 3x, and dividing both sides by 3 gives you x equals 7. Now, you might have taken some different steps to get there, but as long as you came up with x equals 7, then you're good. For this one down here, I'm going to add 5x to both sides. Gives me 21 plus 4x equals negative 3. I'll subtract that 21 from both sides. Gives me 4x equals negative 24. And dividing by 4 gives me x equal to negative 6. Again, you might have taken some different steps to get there, but as long as you arrived at this answer, then you did well. Alright, if you need anything clarified, you can go back and watch the video again. You can look up some other videos on solving equations if you'd like. Otherwise, I suggest you work on the homework.